Right, I'm just going to work out the pH for the graph on the left. I'm going to work out the pH at the start, the halfway, and the equivalence point. The pH at the start is worked out by calculating the pH of the starting weak acid or weak base. The very first thing that we have to do here is have a look at our question, and here we've got dioxyamide there, and we can see that it's the conjugate base of the weak acid, the pK of the weak acid that's given below. So what we're going to be having in our solution for a start is 0.2 moles per litre of a weak base. So we're going to do a weak base calculation to work out the concentration for a start. Okay, if I just move this to the side, weak base concentration. First thing we're going to have to do then is work out a pKb. So pKb equals 14 minus 11.65 equals 2.35. Okay, so these are our pKb. Okay, from our pKb we can work out our Kb by just doing 10 to the negative pKb, which gives us 4.47 times 10 to the negative 3. Okay, now I've worked this out, I can calculate the concentration of the of OH minus hydroxide in my initial solution. Okay, and I do that by the square root of the Kb, 4.47 times 10 to the negative 3 times the original concentration, which was 0.2. That answer is 2.99 times 10 to the negative 2. From there, work out my pOH. Oh, sorry about that, that's a bit messy. And that equals 1.52. Okay, and from there work out pH by subtracting the pOH from 14, which is going to give us an answer of 12.48. Okay, so that is the pH before any of our strong acid is added. Okay, just let me put that to the side. Okay, so that's a pH for a start. Let me just plot that on the graph. 12.48. Oh, it's just, sorry, up here somewhere. There we go. Next thing we do is we can work out what the pH is halfway to the equivalence point. Now, in order to do that, we have to work out the equivalence point. In this particular instance, the weak base's concentration of 0.2 moles per litre and the strong acid we're adding has a concentration of 0.1 moles per litre. Assuming that they react in a 1-to-1 ratio, which they do, is what will happen here is that I will need twice the volume of nitric acid to react with my weak base because it's half as concentrated. So I have 10 mils of weak base for a start, so my equivalence point must be at 20 millilitres. Okay, so the equivalence point is at 20 millilitres. What that means there is that halfway to the equivalence point is going to be 10 millilitres. Sorry. So at 10 millilitres, we get the following situation. We can use what's happened is our weak base here, okay, has reacted with our nitric acid, HNO3, and it's produced the conjugate acid, weak acid, H2O2, plus the nitrate. Now, halfway to the equivalence point, half of this has reacted to produce this. What that means, if we started with 1 mole of this, we now have half a mole left, and we have half a mole left of the others. That is, the amount of each one's going to be the same. Because they're in the same solution, their concentration will therefore be the same. And we can use the following equation, the Ka equation for the reaction of the weak acid with water. So we can use the Ka equals H3O plus times HO2 minus H2O2. Okay, rearrange this and we get that H3O plus equals Ka times H2O2, oops, sorry, wrong place, 2 over HO2 minus. Okay, what we can do here, these two, remember, have the same concentration, so we get H3O plus equals Ka. We can rewrite this and say, do a negative log of this, and we get the pH equals the pKa. So at the equivalence, halfway to the equivalence point, which in this case is at 10 milliliters, the pH equals the pKa. What that means is that on our graph, okay, at 10 mils, I can put in the pH equals the pKa, and the pKa in this case is 11.65. So that is up about here. There we go. It's 2 points plotted on our graph already. Okay, the last part, the last point we're going to plot on our graph is going to be at the end point, or the equivalence point. Now, at the end point or the equivalence point, it's important to note the following. Okay, and the following is that our weak base, which is HO2 minus, has reacted with our strong acid, HNO3, nitric acid, to produce hydrogen peroxide, our conjugate acid, plus NO3. Right, so it's done this. What's happened essentially is all of our weak base has turned into weak acid. So at the end point, at the equivalence point, we now have their weak acid and our nitrate, which is just a spectator ion, it's neutral. So we essentially have a solution of weak acid. However, our solution of weak acid, even though it has the same amount of weak acid as we initially had of the weak base, has now been diluted. Now the reason it's been diluted is initially I had only 10 milliliters of this, but I've added an extra 20 milliliters of this. So now our total volume is 30 milliliters. So even though I have the same amount of weak acid as I did my weak base, I now have it in 3 times the volume. That will mean that the actual concentration of my weak acid now is going to be 1/3 of the concentration of the original weak base. Now I work out the actual concentration by taking my initial volume in dividing it by my total volume when we're at our end point, or the equivalence point. I multiply that by the initial concentration, which was 0.2 moles per litre, and I get my concentration of my weak base, 0.0667. And from here, okay, it's just an easy step. It's a weak base calculation, so we know that H3O plus is going to equal to the square root of the Ka, which is 2.24, times 10 to the negative 12 times my new concentration here, 0.0667. Remember, that is the concentration of my weak base at the equivalence or end point. That ends up being 3.86 times 10 to the negative 7, okay, and that gives me a pH of 6.41. Okay, so that there is my final calculation for the end point or the equivalence point. I take my graph back, let's just make it a bit bigger. Let's put this in here, which was 6.41. So at 20, we have a point of 6.41, which is going to be about here, right? So we've got a point here. Remember, the point at halfway to equivalence point was 11.65. Okay, so now we just sketch this graph. We note that at halfway to the equivalence point we have what's called our buffer region, so we have a nearly vertical line like this. We note that at our equivalence point we're going to have, nearly horizontal line at the buffer region, we're going to have a vertical part like this, and then we just fill in the curves. So here's the curve from the start. Join it up. Okay, well, this is not the best drawing in the world, but here we go. There we go, here's the shape of our graph, with our 3 points specifically known. Okay, hopefully that helps. Oops, sorry.